I'll do a quick introduction. Good evening, welcome. Thank you so much for joining us. My name is Priyanka Punt. I work here at GradRight. We'll be starting in just another minute or so. We're waiting for a few more people, but until they join in and we officially begin our masterclass, let me once again welcome you and thank you so much for spending your Wednesday evening here with us at GradRight. We're so excited to bring you the second in our series of masterclasses. As you can see on your screens, this evening's masterclass is with Worcester Polytechnic Institute. It's one of the oldest and most prestigious engineering schools in the United States. It's got a fascinating history. We'll be learning a little bit more about it over the course of the next hour or so. But this masterclass is really, really special. We're talking about building a smart world and what that requires. It'll be a really fantastic, really insightful, exciting 1 hour. And who will be leading your class? It's Dr. Alex Woodlinski. He's the Associate Dean of Graduate Studies at WPI. He's also a professor of electrical engineering, as well as robotics engineering, as well as director of the Wireless Innovation Laboratory. So Dr. Alex, hello and welcome. Good morning. It's a very cold morning where you are. Thank you so much for joining us.
Thank you, Priyanka, and good evening to you and welcome everyone. Very excited to be here and thank you again for the invitation.
We're so excited to have you. Right before we do begin this evening's masterclass, so I would love to get a sense of where students are on their journey. We'll throw a quick poll up on your screens, and if you could let us know, are you actively looking to apply for master's programs? Have you maybe already applied and are waiting to hear back? Are you kind of still exploring? Is a master's really the right decision for you at this point in time? We've got a global slowdown, and I can understand it's an expensive proposition to go abroad for your master's. So we would love for you to take 30 seconds, answer the poll that's on your screens right now. And as you do that, a quick word about what we do here at GradRight while you're answering that poll. Some of you may know about us, some of you maybe your first event with us. So welcome wherever you are. Thank you so much again, as I said, for taking the time to be with us this evening. GradRight, as some of you may know, is an online platform. It's completely free for students, and our aim is to help you as Indian students figure out what master's program to apply to, and also how to fund that degree. How do we do that? We use data, we use tech, and we have an AI recommended powered recommendation engine where you fill out what's important to you. Is it a research-based university? Is it a university that has a really strong placement record? Whatever your aims and ambitions and goals are in your personal and professional life, we take all of that into account. It's a really simple form. It takes you just a few minutes to sort of put in your data. Based on that, we give you a personalized recommendation short list of programs that you should apply to, based on your profile, based on your test scores, based on what your goals and ambitions are. Once you have that shortlist in place, you can connect with mentors at these universities. You can come to events like these where you can see, okay, is this master's program really, what it's going to be like for once I'm actually on campus? Should I go for this program? Should I go for this university? Whatever your sort of concerns are as a student, as an international student particularly, we try and do as much as we can to try and help you address some of those concerns and answer some of those questions. Once you've figured out exactly what program to apply to, we also help you fund that degree. How do we help you do that? We've got an education loan bidding platform where you can come on, tell us sort of what your estimated expenses are, your living expenses, your tuition fees, if you've got scholarships or not, how much of an education loan it is that you really require. Based on your requirements, banks actually compete to finance your loan. It's pretty revolutionary. You don't have to go from bank to bank, saddled with paperwork, worried about whether or not you'll get a loan. It's all online. Again, it's completely free for students. So it's a really simple, seamless, tech-based process. And we really hope that, wherever you are in your journey, you find some value in GradRight. With that, thank you so much for joining and answering that poll. Interestingly, 73% of folks are actively exploring master's programs, and most are looking for spring in 2024. A few for fall 23 as well. So fantastic. I think you'll find huge value in this masterclass. And a lot of you are actually interested in electrical and computer engineering. Half of you, so fantastic. You're in the right place, you're in the right class. And as we say, class is in session, and it's over to you, sir.
Thank you, Priyanka. Very excited to present a little bit about what electrical and computer engineering is, and exactly how what's involved in say a graduate program in electrical and computer engineering, what type of research, what sort of courses you would take, how would it prepare you for a future, and what does that future look like? All right. So as the title says, it's about building smart world, and I'll explain what smart world is in a minute, because what the heck is smart world? Is it a marketing term, or is it something deeper than that, right? But it's what's after that initial three words in the title that I'm going to be really focusing on, because that's the foundation of what smart world is all about and how electrical and computer engineering builds it, right? Which is connectivity. Wireless connectivity, wired connectivity, visible light connectivity, you name it, and data and semiconductor devices and sensors and actuation and embedded processors and computing processing, like all of these factors, okay, they lead to what our conveniences are today, our cell phones, our smart devices, our smart streets, like all this automation, the internet, how we interface with the cyber world, right? So in this presentation, I'm going to go into a little bit of the details about what is our information age today, and why is it the smart world, right? And so a little bit about myself. I'm Alex Woodlinski. I'm the Associate Dean of Graduate Studies, and I'm a professor in electrical engineering and robotics engineering. I also lead a research lab called the Wireless Innovation Lab at WPI. So let me go into a little bit about what the presentation is all about. I'm going to introduce about my research lab a little bit, to provide context about who I am. Why am I presenting electrical and computer engineering this way? Because if you ask any of my colleagues in WPI in electrical and computer engineering, they're all going to present what their viewpoint is about ECE. So that's the shorthand for electrical and computer engineering. And what's really important is that even though they have different perspectives, we all kind of look at the same sort of program and the same sort of discipline. It all has kind of a common thread, which is relating the physical world that we live in and the cyber world, the algorithm world, the computing world, the information world, the internet, like all these servers and all these conveniences out there, right? And so we're that glue that connects the cyber and the physical worlds together, right? I tend to look at that perspective from a connectivity angle, but I have friends of mine, colleagues of mine, who look at it from a security standpoint, from a power engineering standpoint, from an embedded processor standpoint. So we all look at different ways the cyber and the physical world connect together, right? So I'm going to give kind of what a perspective of that smart world, what that connection looks like between cyber and physical world, okay? And one very important way where we engage with the cyber world is this thing called the Internet of Things. So I'm going to go a little bit into what the heck the Internet of Things is all about before going through a couple of use cases to kind of highlight how the Internet of Things, how those fundamental concepts with respect to ECE and that glue between the cyber and the physical realms connect together. Specifically, smart agriculture, huge impact in today's society, especially with things like climate change and the like, and then smart transportation, which is also equally as important in terms of getting people from point A to point B and really improving people's quality of life. And then I'll give some future predictions because that's what I love doing, right? Okay, so quickly, so my research lab, there's a physical space, there's research going on, but really to me, like what my research lab is all about, it's about people. It's about people who want to innovate, who want to kind of like make the world a better place and really kind of take the current state of the art of knowledge and really advance it, okay, to the next level. Right. So if there are challenges, if there are really difficult, challenging issues that face humanity in terms of like, shucks, like, how do we make agriculture smarter? How do we deal with limited water supply in an area of the world that, really depends on reliable food to be grown? Otherwise, there will be issues with respect to the well-being of the people in that region, as a good example. Or how do we get people who are unable to drive or cannot financially purchase their own car, and that's a limiting factor in them getting better jobs, right? Or just getting from point A to point B. Like coming up with technologies that support them, it's those types of problems that the Wireless Innovation Lab support. It supports the people, supports their education to create new solutions that help society solve these challenging issues, right? And make the world a better place. And I really do mean that. And so grad students, undergraduate students, other faculty, my lab is all about coming up with these innovative and new solutions. And in general, that's how you should be looking at graduate studies in ECE. You're going there not only just to take courses and to get a degree, but it's getting the latest tools and knowledge in order to make the world a better place, to advance the current state of the art, and really kind of like, that glue between the cyber world, which has a lot of potential, and the physical world, which, things like climate change, things like overpopulation, things in terms of quality of life, trying to combine the two to continue the advances that we have been seeing over the last 100 years, okay? About me, that's a great photograph of myself. So basically, I've started WPI since 2007. I'm currently hold the rank of full professor. I'm tenured. I'm the Associate Dean of Graduate Studies since 2021. I also was the president of my professional society, which is the IEEE Vehicular Technology Society from 2018 2019. Received quite a bit of sponsorship. That's really important in terms of supporting the graduate studies of many of my students who do a very heavily research-centric, either master's or PhD degree, and from a variety of different government and industry partners. I've published a lot. That's very important to get new ideas, new knowledge out there into the research community, because that's what helps move the current state of the art from an academic standpoint, and publish quite a bit in order to get those ideas out. In terms of what my lab does, I do anything wireless, right? So whether it's connected vehicles, whether it's machine learning for wireless communications, satellite communications, 5G, 6G, wireless prototyping and test beds, like my lab does it all, right? And so my research lab is very heavily applied research centric, right? But other colleagues of mine in electrical and computer engineering, they might be more fundamental in terms of the type of activities they pursue. Some are even more applied research, let's say, and again, like I do more wireless. I have colleagues of mine who do embedded processing, cybersecurity, machine learning, signal processing techniques, RF, IC design, you name it. Like we cover in ECE at WPI, a variety of different topics that all kind of are like at the cutting edge of today's society, right? You hear a lot about semiconductors, you hear a lot about 5G and 6G, you hear a lot about machine learning. WPI ECE does it all, right? And you'll be able to find professors who both teach classes in grad classes in these cutting edge areas, as well as supporting grad research in case you want to do a master's thesis or a PhD dissertation in these topics. Okay. In terms of where we're located, yes, that's kind of like, over 100 years ago, that's what our building looks like, but it's gone through many renovations, and we do a lot of there's the building itself has been updated to the 21st century to do 21st century type problems that need to be solved with cutting edge solutions, with the best and brightest grad students and faculty mentors available, right? So here's a photograph of one of my former PhD students. He currently is employed at Analog Devices that does a lot of these like hardware solutions that they also sell to universities and to government and to industry in order to come up with the latest and greatest solutions in the wireless domain. But he's one of many examples where we graduate students that not only go into academia, but they also go into industry as well. And one thing of note, where WPI is located within the United States, we're in one of the tech hubs of the United States. Sure, you hear about Silicon Valley, but the Boston area is extensively, I would say, populated with many very large high-tech companies, as well as many startups. So you'll find a variety of different topics, whether you want to go into analog IC design, wireless connectivity, machine learning, or a variety of different topics. So we're in one of these tech corridors, if you will, of the United States, if not the tech corridor rivaling Silicon Valley. In terms of financial support, my research lab, again, is a mix of government and industry. And the thing is that, in terms of finding opportunities to financially support your graduate studies, master's or PhD, you'll need to talk with professors who you would want to work with, right? So that's definitely an opportunity if you're doing something more along the lines of applied research. Of course, if you do a strictly course-based master's degree, those opportunities are maybe not as readily available. But the thing is, there's still a lot of great opportunities in terms of finding co-ops and internships locally, regionally, just down the street. Worcester is about 50-some minutes drive away from Boston, but there are a lot of companies between here and there where you can find internships and co-ops that can help financially defray some of the costs of your graduate studies. And again, that's something to really explore when looking at this, us as an option for pursuing graduate studies. Now, I've also published several books, again, mostly wireless centric, machine learning centric, prototyping, it's like that. That's kind of like, my gig. I do a lot of like proof of concept building wireless connectivity, because to me, the future is wireless, right? Like your smartwatch, your smartphone, your smart toaster, your smart home, your smart streets, your smart cars, all of these are connected, right? They're all exchanging information, because information is key for making our world a better place, the quality of life, right? The smart world, right? So, and that's the thing, like, what does the smart world look like? This came from the internet, from the US National Science Foundation, great diagram, and if you look at it, it's like, it's a great kind of cross section about what the smart world means, right? We have green energy, right? We've got windmills, we got solar panels, and we have communications, localization, navigation, we got airplanes and helicopters flying in the air, and and hundreds or thousands of them, and they don't collide because they're all able to know where they each are, and it's almost like ballet, right? They all know where they are, they know where they're going, they land with precision accuracy in different airfields and go across country, across oceans. We got electronic healthcare, smart healthcare, pacemakers, and other sensors that really improve the quality of our life, right? Like, keeping track of like our pulse oximeter readings, about like heart rate and all that jazz, right? Smart infrastructure. I don't know how many people here live in a house with like at least one smart appliance, right? So let's say your oven, like your lights, let's say there's some feature in your home that's like senses whether it's being used or not to save electricity, to be more convenient, to automatically turn on, and really improve the quality of your life. smart environmental sensors, especially when we're dealing with things like climate change, as well as environmental awareness to take care of pollutants in the environment and such. And then smart and connected vehicles, because and autonomous vehicles, because that's the future as well, especially buses, especially tractors, especially trucks in terms of transporting goods and such. But remember what I said about everybody looks at things through their own lens. So I'm a wireless communications person. What do I look at? Well, I look at the technologies that enable this smart world. I look at 4G and 5G with respect to the smart grid for the power being generated from both renewable sources, also from non-renewable sources, so we don't waste energy, and it's always there. It's always reliably on when we most need it, right? In terms of aircraft traveling or in the air and stuff, I think of things like ADS-B and GPS and radar in order to make sure that when we do air travel, we're safe, right? And we get conveniently from point A to point B, and we can, again, elegantly do that ballet, but everybody's in the know. Everybody's communicating with each other. We know where all the aircraft are in this air into space, right? And then also in terms of those health sensors, there are things like body area networks. That, for instance, that pacemaker, right? That smartwatch, like all these sensors on us, especially if, let's say, we're trying to get well and we don't want to spend time in a hospital. We want to be outside of the hospital, but the doctor, the nurse, those medical practitioners are still following us to make sure we make good progress to good health, right? So in terms of like at home, these smart sensors, we have Wi-Fi, we have Bluetooth Low Energy, Zigbee, sensors in the environment like LoRa, and again, Bluetooth Low Energy and Sigfox, and autonomous vehicles, things like 5G and CV2X. So everything here, all these smart technologies, all these smart applications, underneath them all is connectivity, right? But the thing is, what exactly, so like, again, like if we take this out, go up a level and look at what are the basic ingredients for this smart world, and where does electrical and computer engineering fit? Because when we go back to this diagram, this is all enabled, 100% is all enabled by electrical and computer engineering. It's now your decision which part of the smart world you want to be tackling. You want to develop graduate level education and skills and expertise in terms of making this world a better place, enhancing these technologies, for society, right? So the basic recipe, again, this is very naive on my part. I just kind of said, oh, okay, what would this look like? Well, here's the ingredients of what smart world would be, okay? So embedded processing, absolutely core, right? Like everything has an embedded processor. Watch, phone, microwave oven, stove, light switch, car, laptop, you name it. Everything has embedded processing in it. It's necessary, right? Sensor technology, right? Like, did somebody come in the room? What's my heart rate? Like, what temperature is my oven set to? All these we need to understand, what does the physical world look like? And that physical world gets translated into digital information that goes into your embedded processing. But then what's the link? Okay, that information that might need to be shared through the cloud or through other embedded devices to make more of an informed decision, that's connectivity, that's wireless, that's me. Or maybe it's wired, right? Like, like small little wires that are like in your walls in your house and such. So additional things, data science and analytics. So let's say you collect this data from these sensors, they get processed by these embedded devices, but then you want to process it and say, okay, what's the deal? Like, what am I actually seeing? Like maybe one embedded device looking at one sensor is not enough. Let's say we have hundreds of sensors connected to hundreds of embedded devices. What do they actually see? Well, that's where data science and analytics come in to kind of get a better picture of like what the environment looks like. Maybe we want to actuate, we want motors, we want these embedded devices to then create physical actions back. So they send data back to actions, codes, instructions to motors and other types of physical devices that, like, let's say, open doors, turn off the temperature in your oven, maybe make a little beep, beep, beep on your watch that says, hey, your heart rate's too fast, you might want to stop running. Right? So then also systems engineering, because you can imagine this is a ridiculously complicated system, right? So like what I was talking about ballet, well, let's say it's ballet with hundreds or thousands of these devices. They all got to elegantly interact with each other. So it's no, and when you do ballet, You don't choreograph for one person and then you have 100 people dancing. You got to choreograph all of them. And systems engineering is really important for that. Cloud networking and then cybersecurity, because there are bad people out there wanting to, like, you know, say, hey, let's mess up this ballet, eh? So, so again, my perspective, this is also very, very ECE focused, but of course I'm biased. I think it's the best focus out there. But you know, the thing is to remember is if you ask somebody from computer science or data science or systems engineering, they'll have a very different perspective. But again, I think my perspective is the best. So, all right. So you might say, okay, like electrical and computer engineering and the cyber physical boundary and stuff. I love this example because like this curiosity should be at the core of everyone kind of going into electrical and computer engineering. Of course, it's not like this is kind of like not cutting edge and stuff, but it's kind of like a cute example about that boundary between the cyber world, right? The information world and the algorithm world, the cloud, if you will, and the physical world, like what we live in, the temperature in this room, the amount of light that's in here, like my voice and communicating to this microphone. So what happens is, so I have a little kid and I'm like saying, you can't really see it. How about this? There we go. So I have a baby monitor, right? And one time, this is the second baby monitor. The first baby monitor went to baby monitor heaven. And I said, you know what? I'm going to take this apart because this was a core technology for several years of my existence when my daughter was born and growing up, because it was kept her safe, improved the quality of life for both my wife and I and my daughter. And I said, great example of the cyber physical boundary where ECE plays, okay? So this is what a baby monitor looks like. There's a camera and then there's a monitor, right? So you have the camera unit and guess what? There's a sensor, there's a camera sensor, there's a wireless transmitter and receiver, there's a microphone sensor, and there's a speaker. So think about it, sensor, what is the environment looking like? So both visually and then from audio. The speaker is a way of me engaging with the environment, in this case with my sleeping daughter or not so sleeping daughter. And the wireless connectivity is to get that information to something very important like the second part, which is the monitoring unit, like my wife and me, because then we need to make decisions. Is our daughter asleep or is she in trouble? In which case we need to go up. And so we need a way of interfacing with that data. So that's the display. We have the wireless transceiver to get that data from the sensors. We have a microphone sensor so we can speak back to our daughter. That always makes her very scared, so we almost never do that. There's a speaker so we can also hear if she's in trouble. And of course, very important, there's a battery supply. So if you open one of these things up, you get a lot of stuff, right? So this is what 21st technology has reduced down to, like a $10 monitoring unit. And so if you crack it open and you look at the individual components, you got like your antenna, you got your you got your basically this one chip that does all your wireless communication needs. It's wonderful. So one IC, one integrated circuit, is what connects, you know, the one sensor device and as well as the monitor, the speaker device and the visual and audio sensor to my monitor. This is like fantastic stuff. And it's a one chip, all designed by like many generations of electrical and computer engineers, right? And then what happens, let's go deeper. That chip, that wireless information, then goes into something called the Sonix SN93330 baseband processor. So that's where you have your embedded algorithms taking the wireless information that comes from that sensors and then processes it into visual data that goes to the LCD display. Fantastic. So it's another chip. And in electrical and computer engineering, especially at the graduate level, this is kind of like your starting point to saying, okay, how can I make this baseband processing work better? What happens if it's under, you know, like, let's say more physical constraints, like, you know, like reduced battery supply, let's say limited embedded processor computational complexity. Suppose I want to put machine learning on it, so I don't have to look at the monitor, but the machine learning algorithm says, hey, that kid moved, signal to the user saying, hey, kid moved, in case like my wife and I are watching TV and we're ignoring, we're never ignoring, but suppose we are, and it's going, boop, 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 you know, the kid's moving. That machine learning functionality would be really awesome, right? And then finally, the all-important battery, rechargeable battery, because everything's on battery. But there's also research being done into batteryless devices as well. And that's also very important because batteries are a really big constraint. The more and more small the embedded processor is, oh, but here's this humongous battery, and it's kind of the Achilles tendon, if you will, of like these embedded devices. So with this like simple example, let's go bonkers. And that's what everybody in ECE does. Like we take, like, you know, we're not going to start off with like baby monitors and stuff, but we go like really into like, you know, into the weeds of very advanced kind of implementations. Like for instance, again, I'm a wireless person. I look at really complex networks of stuff. It could be baby monitors, but it could be cell phones. It could be sensors. It could be vehicles communicating with each other. It could be smart homes, smart transportation. It could be anything. But imagine we have tens of thousands or hundreds of thousands of these devices that are all sharing information with each other across this really complex network. That's where I play, right? And there are going to be a lot of challenges with respect to making everything from baby monitors to laptops to cloud servers to cell phones, you name it, all trying to communicate with each other, right? So that's my gig, right? And so, like, for instance, we hear about 5G and such, but, you know, what the heck is it? Well, it's an evolutionary step from 4G, and 4G is an evolutionary step from 3G, and you get the picture. But what 5G is this like the evolutionary step where everything is connected. Everything is connected. Sure, there's talk about millimeter wave. Sure, there's these crazy data rates, but it's really about putting everything under a systematic umbrella that includes IoT devices, it includes smart sensors, it includes smart appliances and smart transportation and smart agriculture and drone-based networks, you name it. Like 5G is about connecting everything, right? 6G, which is on the horizon, is making that connectivity smarter. But 5G right now is just connecting everything, right? And for a lot of different applications like connected vehicles, telemedicine, and virtual and artificial reality. Oh, that's so cool, right? And cloud-based gaming. So what happens is the game changer really is about IoT. It's about IoT. It's about IoT. It's more than just this. It's about tens of thousands, hundreds of thousands, millions of these things all over the place across a town or a city, in a university, a campus, you name it. And then trying to innovate, trying to come up with solutions, because imagine you have hundreds or millions, hundreds of thousands to millions of these things all connected to the 5G network. I can tell you right now, that's a non-trivial problem. And we need smart people to come up with solutions to take on lots of problems associated with this. And there are a lot. There are an insane number of it, right? And so that's what people are trying to do right now in the 5G world, right? So, and here's some articles kind of saying, hey, heads up, IoT and 5G is going to be a big problem, right? So Internet of Things, the marketing diagram, everything's connected. So everything is connected. Watch, your headphones, your laptop, your cell phone, your car might have multiple devices, your home, you name it, everything is connected. And this is what the reality of grad level research, grad level education is all about. It's about taking these processors, and you know, the thing is, it's not a challenge if you take a $1,000 embedded processor with multiple cores with unlimited energy to take an infinite number of really awesome sensors to make decisions. No, that's too easy. We're talking about the hard stuff. We're talking about super limited computational complexity, right? We're talking about like MSP 430 type devices or Arduino type processors that have very finite amount of processing power, running machine learning algorithms with almost no battery supply, trying to communicate wireless information over miles, right? And that's the reality, and that's the hard problem, right? So it's like a challenge. I come with you and I dump something on your desk, and it's like, make this work, okay? In the middle of like 40 degrees Celsius weather, in the middle of a countryside, to communicate with a wireless base station 2 miles away. Have fun. Oh, by the way, there's almost no power. You're going to have to be solar. You know, that's the type of research that is like IoT research, right? Oh, and I want you to do machine learning on top of it because everyone loves machine learning. So this was actually one of my PhD students who is a visiting PhD student to WPI. He was a PhD student from Université Gaston Berger from Senegal. And you know, the thing is, in Senegal, right, I'm going to talk about Senegal, they are at the forefront of one of our worlds, one of our planets, one of humanity's biggest challenges, which is sustainability and climate change, right? And the game changer, humanity needs to come up with smart solutions because we're in for a ride. We need to come up with solutions that can solve for these really difficult challenges, because we need to, there are going to be a lot of people that are going to be affected very negatively by climate change, right? And we're seeing it, and I'm going to get into it in a minute. So Emmanuel Effa, and there's another PhD student also from Senegal, who looked into the really hard problems of smart agriculture, because food security is one of the #1 challenges that face today's society, right? And we're seeing it, and it's not just Africa, it's around the world, right? So in terms of like IoT, we got to think about sensors. What are we sensing? How accurate should these sensors be? How much power do those sensors take? Computing. What type of computing resources we need on these sensors, these IoT devices? How much power do we have? Does that have to be batteryless? Is it going to be solar? Like, what are the limitations there? Connectivity, again, like, how accessible is the data? Because a sensor by itself is useless unless it's used in order to do an action to take care of whatever it's trying to monitor, right? And then the environmental conditions, because I can tell you, electronics in very humid conditions in 45 degrees Celsius weather isn't going to be very good, right? So what happens is sensor technology has gone down really in cost. Like, so my father-in-law, since he retired, he loves electronics, and he's like, every time I go over, he's like saying, "Hey, Alex, look at these cool sensors I can buy for almost no money." It's like, $23 is really low cost, like in terms of the ability to, like, to buy these sensors with this type of functionality. And then you connect it to your Arduino, your MSP430, or some sort of like variant of it that again is just about $10, and you can do a lot of stuff, like everything from like carbon monoxide sensing to water sensing to temperature sensing, you name it, right? And so then you have choice of computing horsepower. The Raspberry Pi obviously is the Cadillac. It's like the top of the, well, I wouldn't say the top of the line, but it has a lot of processing capabilities, but it also requires a lot of power. So, you have that trade-off versus the Arduino versus the MSP430, which is the exact opposite end, which is like very low computational power, but very low battery utilization, but, like limited feature limited functionality versus very, very high functionality. But you could probably drop a whole bunch of MSP430s in the middle of nowhere with the right design to do, let's say, sensing of your farm, sensing of your food, to see it's not shriveling away because it doesn't have enough water, right? And a Raspberry Pi, on the other hand, you could do a lot of stuff with it, but you better have a lot of power to drive it in order to make sure it doesn't lose power very quickly, right? So you have to think about computing performance. You need to think about how much power it takes. And also the other thing is ease of implementation. Raspberry Pi has its own OS, Raspbian. You could also put, let's say, your own operating system, let's say Ubuntu, and play around with it as well. So you can prototype that way. But Arduinos, you need to use like, their software development environment, or the MSP430, so it's a little bit more trickier, but it's going to be much more lean, right? And then power, the thing is, you can get, like, I actually bought the thing in the top right just a few days ago. You can get these really big 12-volt bricks that are rechargeable. You can have solar panels. You can have a finite power supply, like, for instance, that outlet. I suspect wherever you are in the world, you can your outlet might look a little bit different than compared to this one. But what happens is your needs and your implementation might be completely different than others, right? And then connectivity. Oh, this is a beautiful one. Like, I actually use it. This is from France. This is the LAW-P4 from PyCom. Beautiful, beautiful implementation. You get 4 different types of IoT wireless communication standards, and it's low power. So you can do Wi-Fi, Bluetooth. Wi-Fi is not really low power. Bluetooth low energy is. but the distance isn't super great. But LoRa and Sigfox, oh, so awesome. But Sigfox and LoRa, you need to have access to the right frequency band and that you're allowed to use it, right? So, and then the thing is, what's your data rates? Wi-Fi is going to communicate a whole bunch of data, but it's going to use a lot of power and, you know, all these trade-offs. The bottom line is, if you're going to do IoT design in electrical and computer engineering as a grad student, you're going to learn very quickly in a very deep way. You're going to learn about all these trade-offs, like all the way down to the core about what you need to know, all the sort of like, you know, every little cause and effect of, I'm going to use this technology, but wait a minute, I need to analyze it for power consumption, data rate, reliability, distance, right? So environmental conditions, this just happened yesterday over here. Like we have like 40 centimeters of snow in the last 48 hours. Temperature is going to be a really big problem too, because if you're in an arid location, electronics don't like that. You can have vibration, again, not really great because mechanical vibrations kind of do bad things to things that are electronic. And then of course, water. Water is the ultimate enemy in humidity to electronic technologies. So use cases, I mentioned climate change. This is something that we as humanity are facing now, wherever you are on the planet. And this is a big problem. Then, you know, we're going to need smart people coming up with solutions. And that's where electrical and computer engineering is. We're at the forefront of this technology, right? We're basically coming up, we're innovating solutions that will help society, humanity meet this challenge. It's a global challenge wherever you are, right? And so the UN has this beautiful interface called Hunger Map, and it's mapping out right now where there's food insecurity, and all of it, 90-something% of it, okay, is tied to climate change. And let's talk about like those PhD students, those visiting PhD students from Senegal. They come from a region called the Sahel. It's the boundary between the Sahara Desert to the north and kind of the lush vegetation to the south. So Senegal is over here on the border with Mauritania, which is mostly desert, right? And what's scary is that decades ago, Senegal had 2 growing seasons. Now they're reduced down to 1. That's very serious. That's very serious because you don't want to have refugees, right? Food migration, if you will, to escape issues with respect to the change in climate and creating food insecurity. This is not only going to affect quality of life, this could really negatively affect lots of people around the world, right? And so what do? Okay, let's look at Senegal. So things you can do is Internet of Things and smart irrigation, right? Like, you know, so instead of just pouring water all over and most of it evaporating and stuff, you can actually use like, you know, drip lines in order to provide just enough water to the vegetation you want to grow in order to produce you know, food, right? And so through this World Bank program, there were these scholars from Africa that were supported, excuse me, across multiple disciplines, but including electrical and computer engineering from Université Gaston Berger, which is from Saint Louis in Senegal. These 2 scholars, so Emmanuel Effa and Fatoumata Thiam, and so their PhD dissertation was 100% focused on developing IoT technologies for smart agriculture, because check out the Google map, the satellite view. That's quite arid. That satellite view, like that's their university campus, right? And so what they did is they did algorithmic development in order to figure out how do we make really smart, constrained, embedded devices that allow us to think smarter in order to analyze the farming situation for our crops and be able to come up with ways of smartly distributing limited water due to climate change in order to grow them and provide food security, right? And so what they did is they did what, like, they took classes, and then they also did a lot of research with me. And that's typical of like our graduate student population, ECE, coming up with applied solutions. And it's hard. It's like, it's not just like put things together and magically, it's not that easy. There's a lot of prototyping, there's a lot of thinking, there are a lot of tough times to come up with solutions. And then they went back to Senegal to test their solutions in the field. Like here we see Emmanuel in the field, right? And this was in 2021, right in the middle of COVID. And what happens is they're continuing to process data to come up with ways, smarter devices in order to solve that. And then the other thing is smart transportation, because again, like, that's very much tied to like, quality of life here in the United States. So, self-driving cars are here. You hear a lot about that in the United States, and the key ingredient is connectivity. And there are problems with connectivity, which is and smart cars, which is trying to spoof the locations of those vehicles, because that's a sensing modality. It's like, hey, I'm located here, when in fact you have a hacker that's jamming you, making you think you're there, but you're actually somewhere else. That's bad news, because the GPS, people have demonstrated, for instance, there's a professor at University of Texas, shucks, I forgot his name, but Todd Humphreys, and he was able to demonstrate how you can spoof GPS to make your autonomous vehicle think you're in one place, but in fact you're in another. So, not good. So what happens is, that's another thing that I do, because GPS is a wireless signal, and my students are looking at ways of using machine learning in order to kind of say, I think you're being jammed, because the information I'm getting, electromagnetic information I'm getting from your vehicle, says you're not there. Your GPS is being jammed. It's being spoofed. Shame on you. And we published this paper, right, in Global SIP several years ago. And we also did some proof of concepts with actual vehicles on the road. It was a lot of fun. And that was published in a master's thesis in 2022. So check it out, right? And then lastly, we just got, like as of last week, we just got this paper accepted. And this talks about like this collaborative work that a whole bunch of PhD and master students between myself, University of Massachusetts, and Lowell, as well as University of New Hampshire, sponsored by Verizon, to come up with ways of detecting when a network of cars are under attack. And this was really cool. We came up with some really cool results. This is going to come out in a few weeks, easily accessible to everybody on the internet, like how to do, let's say, the detection of what we call phantom car attacks. All right. So predictions, everybody sees these Gartner curves. And IoT right now is in this place called the trough of disillusionment. There was a lot of hype a few years ago, IoT this, IoT that, IoT, and everybody's like now saying, how do I make money off of this? That's what people are thinking about right now. And it's people like yourself getting cutting edge in education and doing potentially research and getting kind of that skill set from world leaders in different types of IoT technologies here at WPI ECE that'll give you the skill set for you to invent and come up with new ideas. And who knows, that can create a great idea that becomes a startup, and you will move out of that trough of disillusionment. You'll move this technology to the slope of enlightenment and maybe make products that will change the world and change the quality of our life. So with that, I want to thank you all, and I'm going to see if there's any questions from the audience. I think there is one that I can see. So, hey, Alex, do you deal with wireless sensor technologies? And the answer is, hey, yes, I do. But that's a great question. So no, absolutely. So what I do is I deal with, like, especially with the agricultural IoT in particular, or just in general, we deal with like different types of wireless technologies. It's not so much Sigfox and LoRa. We've been looking a lot at like Bluetooth low energy, and we also build custom wireless protocols as well. There's also a lot of 5G protocols that are being rolled in that also focus in the IoT space. But for instance, I teach a senior undergraduate class, and the nice thing about ECE at WPI is that we not only, you're not only forced to take graduate level ECE classes to get credit for. You could also take senior level, 4,000 level undergraduate classes, but there's a limit. You can only take a maximum of 3 of those to count towards your undergraduate degree. And what's important about those is a lot of those courses are very applied. So the senior level undergraduate class that I teach, we build from scratch Bluetooth Low Energy transceivers using software-defined radio technology. So that's like, and that would be like a great segue for like getting your hands dirty with respect to building a wireless sensor technology. And then afterwards, you can then prototype other types of sensor technologies using proof of, like, using software-defined radio technology, using Python or Julia or whatever sort of like programming language that you so choose. Like some people use MATLAB or C, C++, whatever's your poison, whatever you like in terms of programming language, totally cool. So, all right, I think, let me see. There's also other things in the chat. Post. I'm not sure if there's any other questions or that's it. I think that's it. So if there's any other questions, feel free to put it into the chat. Otherwise, I think Amanda has a few things to say about WPI and all its awesomeness, and especially about electrical and computer engineering. So and I'll hang out until the end. So I'm not sure if Amanda, if you want to take it from here, I'll stop sharing because otherwise people are going to see the WPI logo, and it's an awesome logo, but obviously I think take it away.
Thanks, Alex. What a wonderful presentation. Thank you so much.
Thank you.
And hello, everyone. Can everyone see the presentation? Or are you seeing my notes? You can see the presentation? Wonderful.
No, we see the notes view.
Let's see here.
Perfect. This is perfect.
Oh wait, what one are you seeing? Sorry, I just swapped it.
The one before this, I think.
Still the notes view. Still the notes view. Yeah, I know. I mean, yeah. Like you might have to like share, like, yeah, like you might like, I'm not sure if you have to share, like it's probably viewing as 2 different devices. Let's see.
There we go.
Yep. Okay. And let's see.
Let's see. What are you seeing now? Sorry. You seeing?
So right now we just see the MS PowerPoint interface and not presentation view and not the full screen.
Oh. Sorry about the technical difficulties I'm having.
Actually, do you want to send me your slides and I can present it and you can talk through them? Would that work?
Yeah, or it
Okay.
should work. Sorry, I have it.
No worries. Maybe while you set that up, Amanda, there is one more question coming in from Jetin. Any suggestions on how to start your journey in the wireless sensor tech and also in hardware security?
That's an excellent. That's an excellent 2-part question. First, I don't know why my video is okay. So while my video is trying to start up, so obviously it's taking classes, right? So I mean, grad classes are going to be very important. And my video is now okay. So it seems like the stars are aligning not so well, but at least audio is perfect. So the idea is in terms of like grad level, it's like it's taking classes. So right now in electrical and computer engineering, we're actually offering, one of my colleagues, and she is like Professor Basima Islam. She's actually offering this coming fall a brand new class in deep learning for constrained embedded devices. I don't know the exact title, but it's it's an excellent starting point with respect to understanding how embedded devices with machine learning, because that's kind of the cutting edge. Like we just hired her, and she's all about sensing technology. She's all about embedded technology, especially when they're distributed, and with respect to applying machine learning on those embedded devices. So she would be a great starting point. So I forgot what the course number is. It's experimental. So I think it's probably like 539, and I forgot what the letter designation is at the end. There's also several wireless courses as well. So there's 538 as well as 5308. And those courses focus on everything from sort of the fundamentals, not the fundamentals of wireless technology, but like the 538 is about like wireless networks just in general, and a variety of how they operate within an environment and how they communicate information between each other. 5308 is like on localization, which is one of the popular topics with respect to wireless sensor networks, right? So other than that, there's obviously a lot of like, there's definitely a few kind of fundamental or introductory machine learning graduate level ECE classes that are offered in the department. In terms of hardware security, there's also a few that are offered. Most people take 578, which is like, I think, Introduction to Cryptographic Techniques. There's also a few other like hardware security classes as well. I forgot the course numbers, but there's definitely introductory courses, like 2 or 3 in each domain that one can take that would prepare folks for then, let's say, once you do that, you can either continue to invest more time and take advanced graduate level courses with respect to those topics, or you can also do a master's thesis or a PhD dissertation if that's what you're looking to pursue in these topics. So in some of these courses also, you might have to take some fundamental introductory graduate level classes, like for instance, probability and random processes, which is like 502, 504, which is linear systems, and very importantly, my favorite is also signal estimation and detection, which is 531, which is essentially am I receiving a signal or I'm not receiving a signal? It's just like that question alone, or just like, am I receiving this thing or not receiving that thing? There's an entire course, an entire area just revolving around estimation and detection. So yeah. So I mean, so I know it's a long question, but it's something that, like, when you're accepted to WPI and you start WPI, you'll be assigned a graduate advisor, and they will assist you in guiding you with respect to the courses to take for a very specific let's say, direction. Sorry, long question, wrong answer, but there's a lot of information. There's a lot of opportunity, especially brand new faculty that have just started with us. So, and a lot of faculty, like we have faculty in machine learning, Zimin Zhang, we have Basima Islam, who just started, and Bo Tang, who's also very much at the intersection between IoT and machine learning, and he's very applied. So like, we got 3 rock stars, if you will, that are teaching advanced classes in these domains.
Wonderful, Alex. Thank you so much. And you really highlighted our faculty there. So thank you for doing that. I don't need to speak to it. You are one of the experts and you know our faculty so well.
Oh, thank you. Thank you.
So thanks, everyone. I apologize for the technical difficulties. I'm Amanda Kegley, Director of Marketing and Recruitment here at Worcester Polytechnic Institute. So I'm going to give you a brief overview about WPI, where we're located, some stats so that you know a little bit about us. And then I'll give a high-level overview of our ECE program, where Professor Woodlinski, who just presented the department that he's in. But WPI, we were founded back in 1865, and we are known for, what people come to WPI for is that we are theory and practice that. So what you're learning in the classroom can be immediately applied outside the classroom. In addition, when you are studying at WPI, as Professor Woodlinski had pointed out, you are in the labs doing hands-on learning, so that your classes are not just technical knowledge. It is actually practicing and utilizing those tools and techniques and seeing how it works. We have over 7,000 students, 5,000, a little over 5,000 undergrad, a little over 2,000 are graduate students. Now, WPI at a glance, as I mentioned, 36% of our graduate students are international students. They come from 89 different countries. All of our graduate students receive one-on-one support from a student success manager that works with you of day one of your classes till you finish your degree program. And they check in with you halfway through your classes to ensure things are going well and connect you to the various resources at WPI, whether it might be to the Writing Center or to the library, getting software discounts, whatever it might be. They're there to help you. In addition, we have over 400 corporate partnerships. And this is with companies that are hiring WPI students, either in internships, co-op opportunities, or jobs as well. And we have 65 different graduate professional development programs for our graduate students scheduled thus far this year. And then you can see some stats on our students that have graduated back in 2021. Now, Worcester, where are we located? As you heard in the beginning, that we are a little cold right now, right? We are located in the United States, Worcester, Massachusetts, over on the East Coast. We just had a snowstorm that came in, which tends to happen. But it is a beautiful area. We are the second largest city in New England. We are in the center of a college town. There's 11 area colleges, great diverse area of students and individuals that live here. There's a minor league baseball team in town. There are restaurants, diverse restaurants, music venues, a theater. It's a great urban area. In addition, it is also close to the wilderness as well. You have easy access to Boston and New York. You actually have a train station here. We're close to Boston, to an international airport. In addition, we have our own airport as well in Worcester, and you can go to the beaches skiing and hiking. It is a tech hub and a biotech hub in Worcester. We do have 4 different schools. We have our School of Engineering, which Alex and faculty that he just presented on house themselves in the School of Engineering. We have the School of Arts and Science, the Business School, and the Global School. One of the biggest things that WPI is known for is our STEM degrees and majors. So that's really a lot of what WPI focuses on. Even within our business school programs, it's really meant for that STEM individual that's looking to apply the techniques into STEM related areas. Now, the master's program requirements. So we have a master's of electrical and computer engineering, so a master's of science, and this is 7 electrical and computer engineering courses with up to 3 engineering courses outside of ECE. And then we have an MEng, a master's of engineering and electrical and computer engineering. And this is 7 ECE courses along with up to 3 engineering courses outside of ECE. And it could include some business courses. So that's the difference between the MS and the MEng requirements. And a lot of our students, as you heard from the professor, our students really have flexibility within their curriculum to focus on their passion and what they want to do after they graduate. So that could be around healthcare, quality of life, security and privacy. It could be around the Internet of Things, what Alex was speaking about, cyber physical systems as well, and robotics, energy and sustainability. It's really up to you to figure out with your advisor, what's your passion, what's it that you want to do at the end, and pick a curriculum that allows you to have that flexibility so that you can leave there with the skills and tools and the research knowledge that you can apply immediately on the job. One thing that we tend to hear from employers is that individuals that are hiring WPI students, they typically are 6 months ahead of anyone else that they hire from a different university because of that hands-on knowledge that they get here at WPI. Now, admissions qualifications and requirements specifically for the electrical and computer engineering program is you need to have a bachelor's degree in electrical and computer engineering, an accredited university, and typically what we see is GPAs of 3.0 or greater. Some fall above, some fall below, but on average, that's what we see. We understand not everyone has this. However, that's typically what we see. And For your application, you need to submit your application, transcripts, 3 letters of recommendation, and your English language proficiency exam. Application deadline, typically we have international students apply by May 1st for your application to be reviewed. This is for a fall 2023 entry, so that your application's reviewed, you can get your visa, paperwork, and then go and hopefully get approved and come to the United States. Our tuition at the moment is $16.10 per credit. For the whole degree, it is a 30 credit program. It's about $48,300. Now, international students, as I spoke, you do need to submit your English proficiency test. We do accept TOEFLs with a score of 84 or better, ITELs with a 7 or better, and Duolingo scores as well is new for us, and we accept those of 115 or greater. To have your test scores waived, you need to be within the US for 3 or more years. Individuals who have 2 or more years of college of study completed within the last 5 years in the United States. We will do that, and anyone that's native in a country that's native language is English also waives those as well. And then this is just a listing of all of our graduate, well, actually I shouldn't say all, we have 50 plus graduate programs, but this is just some of our programs that we offer. And we do offer our classes both on campus and also online. And then if you want to connect with us, here's our QR code that you can scan. In addition, you have our contact information. So you've probably received an invite from us from GradRight to apply to WPI because of your profile matched requirements. So you can also apply and we'll reach out to you from there, or you can scan this code and we'll send you info as well. But with that, I just want to say thank you. And it was nice speaking with you all. If anyone has any questions around WPI, application requirements, admissions, etc., I'm here to answer your questions.
Wonderful. Thank you so much. We are almost, I know, out of time, but if anyone does have questions, now is the best time to ask. We've got Alex and Amanda's undivided attention, at least for the next few minutes. So please feel free to drop your questions in the Q&A box. I did want to say thank you so much. I think that was such an interesting insight into what a class at WPI might look like. And I think often for an international student, especially a student from India, just getting a sense of that US classroom experience can really make all the difference in understanding what it would be like to really be on campus, be in that program. So I think thank you so much, first of all, for allowing us into your classroom and sort of showing us what that would be like. And Amanda, thank you so much again also for sharing a little more in depth about WPI and sort of the program and the admission requirements. We seem to have a pretty quiet audience at the moment, so I think we can probably wrap. But Amanda, if there were questions, what's the best way to reach you?
Oh yeah, so the best way to reach us, and I can put it in the chat, is at grad@wpi.edu. Write to us and we'll answer all your questions.
Amazing. And I think, Amanda, sometimes students can just assume that, the admissions office is just this one big scary place. There's no real humans there, but people are out there. They're willing to help, even prospective students, right? That's the whole idea. So please.
And our enrollment managers here at WPI, they're all program specific. So they're knowledgeable within that area of study. So they can answer any of your in-depth questions that you might have around studies. And in addition, if you want to connect with students, international students, we also do that as well, and allow you to connect with them, learn about their experiences, and also connect with faculty. So we're here, we're real people. We help a lot of students, and we actually connect with a lot of our students through one-on-one, so through Zoom calls. So we all have scheduling links. So if you ever want to connect with someone live, through video, through the phone, we're all available.
Amazing. Thank you so much. And I will not take up any more of your time. Thank you so much. And I'm sure you've got very busy mornings ahead of you. But again, thanks for taking the time to speak with our student community. And I hope this is sort of the first of many more masterclasses with WPI in the future for GradRight. So thank you so much.
Wonderful. Well, thank you, everyone. Nice meeting you.
Nice meeting you.